Okay, so this video is just practicing firstly expanding brackets using the distributive law, and then secondly simplifying expressions with like terms. Now both of these we did at the end of term 3, but you're going to need to be confident with these for our next week or so of work. Just a little side note, all of the examples I've got here are called expressions, not equations. And that's because they don't have an equals and another term here to use. So I can't solve these because there is no equal sign, but this skill that we're doing here is important for me to equations in a little while. Okay, so again, distributive law, we're timesing whatever is outside here with whatever is inside the brackets. And with these questions, I actually do this with my pen, so that I don't forget to do something and I know exactly what I'm doing. So 4 times x gives me 4x plus, because there's a plus here, 4 times 3 gives me 12. Okay, and that's finished. Okay, now I've got 6q, 6 times q, sorry, gives me 6q, minus, because there's a minus in my brackets, 6 times 4 gives me 24. Okay, now I've got 5 times 3a. So here I've got a number outside my pronumeral here, not like the other questions. So I can combine those because it's a times. 5 times 3a, 5 lots of 3a, that's 15a, plus 4, so 5 times 4, 20. Okay, I'll just do another example here of a slightly different nature. Let's say I have 2a and then I had b plus 8. Okay, so this would become 2a times b would be 2ab plus 2a times 8, 16a. Okay, maybe just one more example, sorry. If I have like 3x outside of x squared plus 2, for example, when I have my 3x here times my x squared, altogether I have 3x to the power of 3, 1 here, 2 here, and all together we add those, plus 3x times 2, 6x. Okay, I can't combine those like terms because this is a cubed and this is a singular x, so they're not like terms, so I can't do anything more with that. Okay. Some more examples here of simplifying expressions, okay? So like I said before, I actually circle the different groups and then I cross them off just to be really logical about it. And usually with our algebraic expressions, we put the things with the pronumerals at the beginning of expression, okay? So even though these have equal signs, I've just drawn them in because I know I have to do another line of working. There's no answer there, so it's not an equation yet. I can't solve it anyway. So I've got a 2x here and an x. They're both got a plus in front of them, so altogether 3x, and a 5 and a 7, and all of these are adding together. So I've got 7 plus 5 equals 12. 3x plus 12, that's a simplified version of this expression. Okay. If I knew the value of x and I substituted it into this and got an answer, and then I substituted it into this, I should have the same answer in the end. They're the same expression value, they're just represented differently. It's like cutting a cake up into different shapes, still the same amount of cake altogether, but different shapes, for example. Okay, now here I have A's and then numbers. So I've got 3A, 8A, both of which are plussing, and then a minus 2a. Okay, so I've got 3 plus 8 is 11a, take away 2a is 9a altogether. Then I have plus 2 plus 5, so plus 7. Okay, down here I've got a's again, so 4a plus 9a, take away 4a. So if you're clever there, you can just see they sort of cancel each other out, I guess, for take away 4. So I'm just left with 9a. Then I've got a 3 and a minus 6. So if I've got 3 and I take away 6 from that, it's actually negative 3. So I would read that 9a minus 3.